Hello guys, we are the students of the University of Windsor and we are currently pursuing a Master's in Applied Computing, and we have created a project for a Fall 21 project on the course Advanced Computing Concepts, which is based on a web search engine. Our web search engine is called the UwinSearch. Moving forward, so our team comprises of Hala, Ajish and myself, Badrinath. The contents of this current presentation is introduction, working of search engine, overview, problem statement and features, UI design flow, graphical user interface, that is the GUI, demo, future scope, summary, and references. Okay, introduction. What a web search engine is. A web search engine is where a particular user searches something which is based on their interest and can get results based on what they want or require. So when it comes to performance, the search engine provides a list of the most accurate matches for the user's interest and on what they really want from the internet. There are various search engines that are currently available, which include Google, Yahoo, Search, and Bing, and the fastest one being Google among them. So to get all this data from the internet, a method called web scraping is used, also known as web harvesting or web data extraction, that gathers all the information from various websites. Using this hypertext transfer protocol or a web browser, web scraping software can directly access the World Wide Web. Moving on, working of search engine, how a search engine works. So using their own web scrapers, search engines scrape hundreds of billions of pages from the internet. Web harvesting or web extraction are frequent names for these web scrapers. A search engine navigates the internet by downloading web pages and following links to those particular sites to find new pages that have been added. So overview. The overview is where we have implemented all the features for our project. These include result scraping, keyword counting, frequency analysis, alphabetical sorting, domain extraction, and the graphical user interface, that is the GUI. We have added a small summary of all these features as well. Moving forward, my colleague Ajish will continue.
Hi guys, this is Ajish. In the advanced computing concepts topic, we went through a variety of concepts based on search engines, which included online search engines, web scrapers, HTML to text, and many more. So with these ideas in mind, we wanted to build a search engine which can return the results to users based on his or her query in an accurate and efficient manner. So we believe, like with this, we built a search engine that is efficient and functional and will produce the desired results for the user. Next slide, please. So for the purpose of this project, we've used web scraping. Web scraping is the process of retrieving a web page and extracting information from it. After the data has been fetched, after the data has been fetched, extraction can begin. A page's content can be analyzed, searched, reformatted, and the data can be put into a spreadsheet or a database. For the purpose of this project, we've used JSoup. JSoup is a Java library for working with real-world HTML. It provides a very convenient API for fetching URLs and extracting and manipulating data. So how our project works is, so when the user enters a search query, we make a request to google.com with the same search query, and we scrape the results from google.com. We put the results through the features we've implemented, the descriptions for which will be in the upcoming slides. And when after the data has been processed by the features, we just display it to the user through the GUI. My colleague Badri will now explain the further features.
Keyword counting is the next feature that I'll be explaining. So what keyword counting is when a user searches for a particular keyword or sentence in the search engine, the keyword is searched or the sentence is searched and it is converted, the converted text files, and with the help of the converted text files, the result is returned based on the user's input. Furthermore, the number of times the words appear will also be displayed. For keyword counting, we used the Boyer-Moore algorithm, where the number of words have been counted or and entered, searched, and the results are searched based on that. What Boyer-Moore algorithm is? Okay, Boyer-Moore algorithm is an algorithm for finding substrings into a strings. The algorithm compares each character of substring to find a word of the same characters into the string. When characters do not match, the search jumps to the next matching position in the pattern by the value indicated in the bad match table. Moving forward. My colleague Hala will continue.
Hello guys, I'm Hala and I'm going to explain two other features of our search engine. First feature is sorting. We decided to implement this feature because we think that it may be helpful for users to see the results of their search in an alphabetically ordered manner. And so we decided to implement this. We use the merge sort algorithm to implement this feature. As you know, merge sort is a divide and conquer algorithm which divide the input array into two halves and then call itself and then halves the array again and do these steps again and again. And then this algorithm called the merge function to merge the two halves together, and the output is a sorted array. This would help users to identify the correct output that is obtained and displayed in the graphical user interface. And with this feature, files are grouped in records that are related to the same individual or the company, and it's more simpler for user to understand and get its required result. Next slide, please. The other feature is domain extraction. Domain extraction allows users to search for a specific domain or subdomain in any text file or other kind of docs, for example, HTML, email, CSV, or other kinds of documents. We can rapidly retrieve all the domains from these text files or other kind of files by using the regex. We need to construct a scraper to extract the URLs in a web page as well as the domain names in those URLs. This scraper is known as HTML scraping or web scraping. With the help of regex, we can identify all the links and URLs in the files presented in the system, so the user can see these elements in a specific part of our search engine. My colleague will continue with next slide.
So coming back to the UI design flow, a particular user searches for a particular keyword or sentence on the search engine that is on the user interface, and it queries to the scraper. From the World Wide Web, it downloads all the pages, and it gets converted from HTML to text, and the text files are stored in the data. These text files are then moved into two subcategories, that is the number of words that appear on the data files and the keywords. So these list of words are then sorted sorted based on the user's preference. Then it goes back, and the results that appear in the user interface, which then the user can click on any result they want or require. Moving forward to the graphical user interface, my colleague Ajish will continue.
So here you can see the screenshot of the graphical user interface that was implemented using Javelin. For Javelin is a lightweight web framework for Java designed to be simple and blocking by default, supporting WebSockets, HTTP, and async requests. So from this screenshot, you can see that on the top we have like the input button, the input field for the search query, and the search button. So when we the user inputs the search query and clicks on the search button, the result is returned in this format, where you can see that we have the domain name of the result, we have the number of times the query occurred in the result, and the first 200 characters of the result. So this is how the results are showed in the graphical user interface. Next slide, please. Here also we have a domain frequency analysis of the results that we're getting back, where we show the user the most occurring domains and how many times it's occurred, and the least occurring domains and how many times it's occurred. So moving forward, we'll have a demo of our project and basic code review. Okay, so we have a demo for our project here. As you can see, this is the graphical user interface for our project, and here is the search query box. You type your query in the search box. So let's suppose we say search for Lancer, and we click on the search button. So what's happening right now is a Google request is being made to the google.com server for the search query Lancer. So when the result is returning back from Google, it is being pre-processed, and then it is being passed to all the features that we've implemented. So after everything, you can see like here is all the results that we formatted and we've shown here. This is the domain name. This is the number of times the keyword is occurring in this. The keyword is occurring in the URL, and here are the first 200 characters of the results in the URL. Every URL here is working. You can actually redirect to the result we're getting, and this is all been sorted in alphabetical order using merge sort. And here you can see it's a domain frequency analysis. Here we see that the most occurring domain is wikipedia.org, and it has occurred 21 times in the result returned by Google, and the least occurring domain is driving.ca, which has occurred 2 times in the results given back by Google. Okay, so now like previous examples, so similarly, if we want to search for like University of Windsor, we just type in the search query in the search box and we click on the search button. So similarly, the request is being made to google.com for this particular search query that we've typed in. These results are being returned and it's being put through all the features that we've implemented. We'll show you the code in a bit. So right now here we can see like similarly here you can see all the domain names, the number of times the keyword has occurred in this, and the first 200 characters of the substring. In the domain frequency analysis tab, we have the most occurring domains, which is obviously www.uwindsor.ca, and the least occurring domain, which is future.uwindsor.ca, and the number of times they've occurred. So that's it for our demo. So now I'll give you a basic overview of all the code that we've implemented. So right now we're in the main class. In the main class, we've actually called all the features that we've implemented. In the GUI package and index.java file, here is the Javelin API that we've used to render the index, and the /search endpoint, which is used to call the main.search function. In the main.search function, the first thing we do is we get Google data from scraper. The scraper can be found under the scraper package right here. This is making a google.com request to the Google. This is making a request to google.com, and the result is then returned back to the main class. Then you can see we implement all the features. The source code for every feature can be found in the features package. It has count keywords, domain name extractor. The count keywords is making a JSOUP request to every URL that we get in result, and then we count the keywords in it and extract the first 200 character strings and everything. The domain name extractor will extract the domains from the values. Merge sort.java is the sorting library through which we sort the results in an alphabetical manner. Frequency analysis uses hash tables to analyze most occurring and least occurring domains. So that's it for the code review.
So Ajish, my colleague, finished the code review and the demo. So I'll be moving on towards the future scope. For the future scope, we're planning to improve the user interface for the search engine so that the users can find the search engine a bit attractive, and we're planning to make the result get the result in a more quicker response, so that the response time will be quicker. Then we are planning to add more URLs so that would benefit the user with abundant data on the World Wide Web. And moreover, we're planning to develop an application for mobile users as well. Moving on to Moving on to the summary, what we have built is a UwinSearch engine that is optimized to search words over the web pages and provide an accurate and precise result based on the user's search. From this project, we gained knowledge in developing a system that relies on data structures and algorithms and evaluating the system based on the methods for analysis, which was programmed with the help of Eclipse development. Then the references we used is the course material from the advanced computing concepts courses that we learned during our class and our labs, and we use Google to search for basic definition of terms. Thank you. Since we have 6 features, our team split the features equally and each member worked on 2 features. Hala worked on sorting and domain extraction. Ajish worked on the GUI and scraping, and I worked on keyword counting and frequency analysis. We used Eclipse IDE to program and test our project. Furthermore, the entire team worked on the PowerPoint presentation as well. Thank you.
Thank you.
Thank you.